With page 2, problem 3, another one where we're asked to find the integral. This time it's from 0 to 7 of the function, and there is no absolute value, so we do want the area between the function and the x-axis. And so we're looking at, I'm going to break this down. We have a trapezoid, and then we have a square, and then a triangle, and then we have another triangle right there. Now this time, because there's no absolute value, this function is going to stay below the x-axis, so we have to consider it to be negative. The area, we have to find the area, and we know that area is non-negative, but because we're actually finding a definite integral, definite integrals can be negative, so it's okay for this part to be negative. So what do we have here? All right, well, we have the trapezoid, or again, if you prefer, you can break it up into a rectangle and a triangle. The area of this rectangle we see is a 2 by 1, so that's 2 units. This triangle is also a 2 by 1, but we want half of that, so it's 1 unit. This square is 2 units by 2 units, so that's 4. This triangle is a 1 by 2, so this is also 1 unit. And then this triangle is 2 units by 2 units, so 2 times 2 is 4, and half of that is 2, but it will be negative 2. So we end up having 2 plus 1 plus 4 plus 1 minus 2. 2 plus 1 is 3, plus 4 is 7, plus 1 is 8, minus 2 is 6. So the answer will be A. For problem number 4, we're given the graph of f of the following, which has the smallest value. All right, so when we look, we see a left Riemann sum, a right Riemann sum, a midpoint Riemann sum, and a trapezoidal sum. Okay, so midpoint and trapezoid sums we know are very accurate, all right, especially when compared to left sums and right sums. So if we're looking for the smallest value, which you see right there, the least value, it's highly unlikely it's going to be the midpoint or the trapezoid sum, because they will probably be more accurate to the actual answer, whereas one of these will be a larger under approximation. So what's going on here? Well, go back to our notes. We see that f is decreasing. All right, so f is decreasing, and when f is decreasing, that tells us that either a left sum or a right sum will be an under approximation or an over approximation. Now remember, if you don't remember the actual how it all works, you can always draw the rectangles. So let me draw one rectangle here in which we have a upper right corner touching, and then let me draw another one where the upper left corner is touching. So you can see, because the function is decreasing, the left sum would be an over approximation. We're going to have that extra area there. Whereas a right sum would be an under approximation, because we're missing that area up there. All right, we're looking for the least value, so that means we're interested in the right sum. And again, just to make sure, the trapezoid sum would also be an under approximation, because this curve is concave down. But if we draw a trapezoid up here, let me just draw that quick trapezoid. Okay, now take a look at the trapezoid compared to the right sum. You can see the trapezoid sum is going to have more area because it's drawing that diagonal, whereas the right Riemann sum is going horizontally across. So our answer is B.